So let's understand a matrix from scratch, solving a system of two linear equation, how we can convert it to a matrix form, and how that matrix is useful for solving that system of two linear equation.
All right, let's break it down. When you have two linear equations, say something like a1 times x plus b1 times y equals c1, and a2 times x plus b2 times y equals c2, you can represent this system with a matrix. The idea is simple. You pull out the coefficients and form a matrix. So you put the coefficients into a grid. The first row is the coefficients of x and y from the first equation, the second row from the second equation. This gives you a coefficient matrix. Then you make a column vector for your variables and another column for the constants. When you put it all together, your matrix equation looks like a matrix of coefficients times a column of variables equals a column of constants. From there, you can solve it using matrix operations, like finding the inverse of the coefficient matrix, or using methods like row reduction.
So, who was the person to introduce this matrix at first?
The concept of matrices evolved over time, but the first person credited with using arrays of numbers to solve systems of linear equations was the Chinese mathematician Zhang Jiu around the 2nd century. Later in the 19th century, Carl Friedrich Gauss formalized methods, and Arthur Cayley truly developed matrix theory as we know it.
So, what was the main contribution from the side of Gauss? And what do you mean by formalized methods?
Gauss's key contribution was creating what we now call Gaussian elimination. This is a systematic procedure for reducing a system of linear equations step by step until it's easy to solve, essentially turning it into something like a triangular form. By formalized method, I mean that Gauss gave a clear universal step-by-step approach, not just solving individual problems, but laying down a framework that anyone could follow for any system.
How that triangular form are helpful?
Once you have that triangular form, meaning the equations are arranged so that each one has fewer variables than the previous, it's much easier to solve. You can start from the last equation, which will have just one variable, solve it, and then substitute backward. This process, called back substitution, makes the solution process clear and straightforward.
What we are discussing till now, and what conclusion will you give to me?
We've been talking about how to represent a system of two linear equations as a matrix and why that's helpful. In short, the matrix form organizes all the coefficients and constants so you can use structured methods like Gaussian elimination. The conclusion? By converting linear systems into matrices, we get a powerful universal way to solve them efficiently and systematically.